Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I am available for code reviews, contracting, and on-site training. In this episode of Will It C++, we're going to talk about the Tandy 1000. And this is an image from the Tandy 1000 article on Wikipedia. But specifically, I want to talk about the Tandy 1000 SL2, which looked like this. This was my first IBM compatible that I ever had. And this ran an 8086 processor running at 8 megahertz. My particular unit, as this says, the SL2 offered 512 kilobytes. Mine came with 512K and a single 3.5-inch 720K floppy drive. I upgraded mine to the fully maxed out 640K of RAM, and then I also added a second 3.5-inch floppy drive to it. So I had two 3.5-inch floppy drives, and I had 640K of RAM. Now this seems like this would be an obvious choice for me to ask, well, can it C++ or will it C++? Are we able to run code compiled with a modern C++ compiler on this device? Now, you might think, depending on your perspective, well, of course you can. It is a PC compatible, and we have lots of compilers for those. But actually getting a 16-bit C++ compiler that can compile modern C++ code is actually an entirely different question. GCC and DJGPP, which we have talked about on this show before, only ever existed for 32-bit. The first 32-bit Intel architecture CPU was the 386, and this was introduced in 1985, which is well before when I got my first IBM compatible. But I didn't have a 386, and the compilers that we know today all require 32 or 64-bit CPUs. Now, on the topic of being IBM compatible, this is the IBM PC. It was released in 1981, and it is effectively the same specs as the device that I want to ask about running modern C++ code on. Now, to be fair, the IBM PC came with considerably less RAM, only 16 kilobytes, and it had a CPU that ran at about half the speed, or a little bit less actually, because the Intel 8088 had a reduced external memory bus of only 8 bits, where the CPU itself could access 16 bits at a time. But it turns out on April 1st of 2017, there was an announcement on Reddit that we have GCC for the 8088, 8086, and 8286 CPUs. So I checked this out, and this is from Mentor Graphics. They have announced a Codebench Lite for IA16, and I have downloaded this for Linux, and I have integrated it into Compiler Explorer as one does. So we have our Compiler Explorer window, and I have a Codebench compiler here. That is the 16-bit Intel compiler. Now let's go ahead and include a couple of normal header files like cstdint here, and just so that we know exactly what size types we're talking about, let's go ahead and add two 32-bit integers. And on our 16-bit processor, it is having to push 4 16-bit registers to handle these two 32-bit values, and then it is having to add them together in pieces and return those back to the calling function. So let's go ahead and add another compiler or two so that we can know what we're looking at here. So we're just going to have a normal Clang here, and if you watched my recent episode on argument passing and structs, then you would be aware of what we can do here, and this is just RDI plus RSI. It's taking the first two 32-bit parameters that are integers, and it is adding them together in a single instruction and returning that with this LEA, and that's going back out to EAX. So it's able to do this in effectively one operation plus the return. Now, every modern GCC and Clang also support 32-bit. So let's go ahead and make another clone of this compiler. And on this one, we will do -m32. And in the 32-bit ABI, it is going to have to push these two 32-bit values onto the stack. So we go back 4, we go back 8, we add them into EAX, and we're done. There's clearly considerably more work that has to be done here on the 16-bit one. And the 16-bit compiler is a bit limited. It is limited specifically to the first 16 bits of RAM. It's effectively a flat address space here. So if I wanted to, for example, write something outside of that memory address space, something like this, then we get this pretty simple, straightforward. We move this value of 15 into memory pointed to here on our 64-bit compiler, on our 32-bit compiler, approximately the same thing again. And then something that just doesn't seem to do anything right at all here. It is calling abort, which doesn't seem like something that we would want to do, and it also doesn't even load this memory address into any register or anything. So it's not able to deal with segmented memory. This is outside of the 16 bits that it's able to address, but that doesn't mean that we can't do anything useful with it. So I have this simple program here, and I'm just going to write some things to the screen. And we've already proven to ourselves that this is a 16-bit compiler, so I don't actually have a Tandy 1000 SL2 that I can actually run this on. The closest that I can get to is DOSBox. But let's go ahead and write to DOSBox. So I'm going to compile this with the compiler that you can get from Mentor Graphics website. So we have our compiler that I have downloaded, and I am going to set the output file name. And this is kind of important. I need to give it the .com extension because this is equivalent to a DOSCOM executable, which was just very simply a flat binary that could be executed. And now I can execute DOSBox, and I can give it this testdos.com file. And yes, that fits within the 8.3 requirements of DOS, and this will launch, and we get the output, "Hello world, I'm in DOS." Now, to be fair, this wasn't a terribly exciting demo, but we did effectively write "Hello world" here. Now, maybe we should try to take it up a notch just to prove to ourselves we are in fact able to take advantage of our zero-cost abstractions and do something slightly more exciting. And, well, to be fair, I don't really have very much else exciting in mind, but we can at least do some sort of lambda calls or something, maybe an immediately invoked lambda expression. If you watch this show, you know that this is the kind of thing that I have fun doing for absolutely no reason at all. So we're going to make a lambda, we're going to invoke it, we're going to return 0 through main like this, and let's go ahead and now turn on optimizations when we build also. So this should do exactly the same thing. And in fact it does. We have our hello world and I'm in DOS. So it is in fact possible to use C++ at least 14 on your 16-bit PC compatible from 1983 or so if you were to choose to do that. So be sure to subscribe, follow me on Twitter, and click on any of the links here.